So we're still working in Unit 1213 here. We're on to Box G, finding equations of lines, using equations of lines to graph. The equation that represents a line always has a very specific form. Okay? It can always be written as y equals mx plus b. Okay? So if that's not on your page, you want to write that on there. Okay? Because all of the formulas that all the equations of lines, we're going to be using this form over and over again. Now, what do these letters represent in here? They represent very specific things. M is the slope. We've been talking about slope in the last couple of lessons. So you know what slope is? It's just telling you how steep the line is. What we haven't talked about yet is what B represents. B is what is called the y-intercept. Okay? It is the value that y has when x is equal to 0. Another way of thinking about it is that it's the point where this line crosses the y-axis. So if we look at this line that we have drawn on this graph here, it crosses the y-axis right here at this point, 0, 2. So B is the value of y when x is equal to 0. So at this point, x is equal to 0. So our B value for this line is 2, because this line crosses the y-axis at a y value of 2. So that's our y-intercept there. What about x and y? Well, x and y are the variables that we're graphing here. We've got x on our x-axis, y on our y-axis. So x and y can be the coordinates of individual points that are on this line, okay, that are going to satisfy this equation. So let's say we wanted to find the equation of this line that we have graphed right here. Well, we know what our value for b is. It's 2. The other thing that we need to make this equation is our slope. Now, how can we find the slope of this equation? Well, I think we want to use good old slope is y2 minus y1, x2 minus x1. And we want to pick 2 points that we know are on our line here. So we already have one of them. We've got 0, 2. Is there another point whose coordinates are easy to get that we know is on this line here? Andrew, what do you think? Do you know the coordinates of some other point on this line? 0 where? Oh, we've got 0, 2 right here, right? The other one that might be really easy to get is 2 what? Ah, right here where x is 2. So you're thinking of this point right here. That's a good one to pick because it's where our line crosses these 2 grid lines. So what are the coordinates of that point there, Andrew? Well, and I can't even write that. Here we go. Sorry. What's going on here? Sorry, 2, 3. Thanks, Andrew. Okay, so we've got 2 points on our line here, 0, 2, and 2, 3. Let's call one of them point 1 and one of them point 2. So this will be x1, y1, and this one will be x2, y2. And let's plug these into our equation for slope. So let's see, y2 is 3, y1 is 2, so we have 3 minus 2 on the top. Down in the denominator, let's see, x2 is 2, x1 is 0, so 2 minus 0. So our slope is 3 minus 2 is 1, 2 minus 0 is 2. So our slope is 1/2. And then we want to put all of this together to get an equation that looks like this. So our equation is going to be y equals m, which is our slope, 1/2, times x plus our value for b, which is 2. So the equation of this line is y equals 1/2 x plus 2. Because our slope is 1/2, our y-intercept is 2. Okay. So we've got two more examples here where we're going to find the equation of a line here. So let's take a look at the next one here. We got another graph. Okay. Find the equation of the line. We need to find two things. We know our equation is going to be of the form y equals mx plus b. We need to find m, and we need to find b. B is pretty easy if you've got a graph. Where does this thing intersect the y-axis? Cool. At -2, right there. So what's our b value? -2. That one's pretty easy. Now, once we've got that point -2, let's just label it with some coordinates. Our x is 0, our y is -2. Next up, we need our slope. Slope we're going to use y2 minus y1, x2 minus x1. We've already got the coordinates of one point. We'll call this x1 and y1. Let's get another point that we know is on this graph here. What do you think here? What's another point that we can use? Nicole. 4, -5 is a good one, yep. So let's label that one as well. 4, -5, and we'll use that as our x2 and our y2. Let's sub these guys in. So our y2 is -5, y1 is -2, so we've got to do minus -2. x2 is 4, minus x1 is 0. So we do our subtraction here. Let's see, -5 minus -2 is like -5 plus 2. So that gets us -3. 4 minus 0 is 4. So we've got our slope, our value for m, and our b. So we put it all together into the equation. Y equals m, which is -3 over 4, times x, plus our value for b, so plus -2, or just -2. And there's our equation. Okay. So in this one, they give us a table of values. Okay? And they're telling us to find the equation of a line. How do we know that the relationship in this table of values is linear? How can we check to see that this actually represents a line? What can we do? If you're given a table of values, how do you know it represents a line? What can you calculate? We did this in Unit 910. Emerson knows. Finite differences, yeah. So let's calculate our finite differences. And I'll just call them the finite diffs, because you know what diff stands for. How do we do finite differences? Let's see, we start at the bottom of the table, we take our y value, we subtract the one above. 11 minus 8 gives us 3. 8 minus 5 gives us 3. 5 minus 2 gives us 3. 2 minus -1 gives us 3. So for our finite differences, we got 3, 3, 3, and 3. That tells us that our line is, Emerson again, linear. It's linear because these are all the same. So we know we got a straight line here. Okay. Now, we worked on this at the end of 910, and we said that, okay, if this thing is going up by 1 every time, okay, the amount that x is changing by is kind of like our run here. Okay? Our run is 1 because x is changing by 1 every single time. The finite differences represent how much y is changing by. Okay? That's kind of like our rise. All right? how much the thing is going up by or down by. So if our run is 1 and our rise is 3, what is the slope of our line? Well, it's rise over run. Slope is going to be 3. So we're halfway to finding the equation of our line here. We've got our slope. All we need now is our y-intercept. Now, the y-intercept occurs at the point where this thing crosses the y-axis. Okay? At the point where this thing crosses the y-axis, x is equal to 0. So what is the value of y where x is equal to 0 in this table? Andrew, what do you think? Where is x equal to 0 in this table? First row. Right. So big red arrow. So what is the y value in that first row? -1. So that is our value for b. b equals -1. Because when x is 0, y is -1. So now we've got everything that we need to make our equation. It's going to be of the form y equals mx plus b. What's our equation going to be? Jackie, what's our equation here? 3x minus 1. And we're so happy about that, we put a big box around it, because that tells us we're done. Okay? All right. One last type of question that you're going to encounter here. Going the other way around. So we have taken the picture of a line or graph of a line and we figured out what the equation is. Here, they are giving us the equation and they want us to figure out, they want us to graph the line here. Okay? So they're asking us first here to graph the line y equals -1/2 x plus 3. The way you want to answer this question, start by figuring out what is your y-intercept and what is your slope. So what's our y-intercept here from this equation? Nicole? +3. So that gives us a point that we can graph. We go to our y-axis, we put a point right there at +3. Okay, next up. What is our slope? -1/2. Now, how can we use this slope to help us graph this line? Well, this is telling us our rise and our run. So our rise here is -1, so we're going to go down 1. Our run is +2, so we're going to go over 2. And that'll give us another point on our line. We can do that again. Down 1 for our rise, over 2 for our run. And then we can connect these points together to form the graph of our line. And it's always a good idea to label this. We'll label this one y equals -1/2 x plus 3. Okay. So we got a second one here to try. Y equals 3x minus 5. What is our y-intercept? Andrew, what's our y-intercept? What's our value for b? You got two choices. It's the other one. The one that's right in front of the x, the one that's touching the x, is always the slope. The y-intercept is always the one that's stuck on the end. Okay? So what is our y-intercept here? -5. So that gives us the point that we can plot, right? We go down to -5. We put a giant dot there. Okay. Now, what is our slope here? Mashaya, what's our slope in this one? 3x, you're looking in the right spot. The x isn't part of the slope, though. It's just the number. You're right. So our slope is just 3. Okay, so if our slope is 3, what is our rise and what is our run? Well, let's think of this as a fraction. 3 over 1. Mashai, what's our rise and our run? Right. Rise is 3. Run is 1. So we've got to go 3 up. 1, 2, 3, and then over 1. And give us another point. Let's do that again. 1, 2, 3, and then over 1. That gets us another point. Connect them all with a nice straight line. Well, that doesn't connect them all. Like I say, connect them all with a nice straight line here. There we go. And if we want to, we can label it. This line over here is y equals 3x minus 5. Okay? And we're done.